Good morning. Welcome back. Last class we did binary search algorithm as well as the program, and we finished with searching wherein you did linear search and binary search. Linear search works on an unsorted list wherein you will not be arranging the elements of the array in any order, whereas binary search works on only sorted list of elements. It can be either in ascending order or descending order. So searching is nothing but finding whether an element is present in a list or not. So now we will see the execution of the binary search program which we did yesterday. So b underscore search is the name of the class. So class name can be anything. In the written program, I think I had given binary search. You can name it the way you want. In the private section, I have an array of 10 elements, maximum of 10 elements, mid, low, high, I, LOC, ELEN, and where EL is the element, N is the number of elements, high is the index value of the last element, and the low is the index value of the first element to begin with, and mid we are going to find the index value or the position of the middle element. In input I am asking the user that how many elements are there, and then I am taking in the array elements in ascending order. That is, I am asking the user to enter the array elements in ascending order. So I am not here assuming that the user would be entering it in ascending order only. I am not checking whether the array is sorted, and if it is sorted, in what order. For I is equal to 0, I less than n, I am taking in, it is put in a loop because it's a repetitive action. So I'm taking in the elements of an array. After that, I have the function search, wherein I'm not using a constructor here. In the search function only, I am giving the initial values of high, low, and LOC. And I'm writing the while loop, wherein I check for the mid value and then compare the element at the mid location. If it is true, then I'm assigning LOC is equal to mid, and I'm stopping the further execution. Otherwise, I'm checking whether it is greater than the mid element, that is the element present at the mid position, or less than that. Depending on that, the high or the low value changes. So after that, once low becomes greater than high, I exit the loop, and depending on the LOC value, I will write whether the element is found or not. After that, in my main, I am just creating an object of the class, and I am calling the functions with the help of object and the dot operator. So let me execute this. So enter the elements of an array. For example, I have 6 elements in an array in ascending order. So I'll say 1, 2, 3, 4, 5, 6. So there are 6 elements. Like, let me say I want to search for an element 4. The entered array is, it is printing me the entered array. The search element is 4 and the element is found in the location 4. Yes, it is the 4th element in the list, as you can see. Now let me run the same program where the element does not exist. Number of elements is 6. Let me say 1, 2, 3, 4, 5, 6. And the search element, let me say I am searching for an element 9. So the entered array is this. Search element is 9 and the element not found. So you can see the execution of it. Hopefully you've understood that. Let me quit my program. Now we'll do the difference between linear search and binary search, which is a commonly asked question. So it is repeatedly asked in the exam. The first one, the list for linear search. This can be used on both sorted and unsorted. It can be used on any kind of list. It does not matter, wherein this has to be used on sorted array only. That is, the array has to be sorted. You cannot use binary search on an unsorted list, whereas linear search can be used on either the sorted or the unsorted. That is, as the user enters. You are not asking the user to enter it in any order. Whereas in binary search, you are asking the user to enter it in order, or you need to check once the array is entered whether it's a sorted list or an unsorted list, and if it is a sorted list, then what order it is sorted, because there is a small change in logic if the for the array in ascending as well as descending order. And this one, elements are accessed sequentially. What do I mean by that? In this, I start from the 0th element. That is, I have the search element and I go on comparing it with the first element, second element, third element. That is in sequence I do. 1, 2, 3, 4, 5. Like in sequence, I go open it, that is, I retrieve the element in that location, compare it with a search element to see whether it matches or not, and if it matches, I stop the search, note down the index value of that, and I print it to the user. Whereas if does not match, I go to the next element. So it is just a sequential. Whereas here, I find the middle element. I don't start from the 0th element. I find the mid value and I directly compare it with the element present at the mid position. So it is direct access. It is not sequential access here. This is very slow because if I have thousands of elements, if I start from the first, I go on comparing element by element, definitely it is slow. Whereas here, I go on splitting the array into half. I don't go on comparing with all the elements. I have direct access. I go on splitting the array into half and go on comparing. So it is faster. It can be used in single and multi-dimensional arrays, because what I am doing is very simple, that I am going to take that, whereas here it can be used on a single dimensional array only, because when I have to find the mid value, that is low plus high, where low and high are the index values, where the index value is only one. Suppose it has two index values, then how will you do that? You cannot do, right? That is the thing. It is used on single dimensional array only. This technique is definitely simple to implement. Yeah, you don't have anything. You just retrieve, compare and put back. There is whatever is the dimension, however is the array sorted or unsorted, it doesn't matter. Whereas here, if it's in ascending order, you have one logic. If it is in descending order, the same logic with a little change, and if it's an unsorted list, you cannot. So you go, it's a complex operation when compared to the linear search. So these are the differences between linear search and binary search. Please have a look, then we can continue with sorting. Here we come to end of our searching techniques, in which we studied linear search, binary search, algorithm, trace and program, where binary search program is also your lab program. Please have a look, then we can continue. So we finished searching. So what are the different array operations we did? We did traversal, wherein traversal is nothing but visiting each element of the array exactly once, and we did a program for that, that is finding the frequency of an element in a list. Then we did insertion of an element into an array at a given location, deletion of an element in an array from an array at a given location. Then we did searching. Searching is nothing but searching for an element in the list, that is whether the element is present or in the list or not. And then we did two searching techniques, which is linear search and binary search. The next one is sorting. What do you mean by sorting? Sorting is nothing but arranging the elements of an array in some order. It can be either ascending or descending. So arranging the elements of an array in order is nothing but sorting. There are different sorting techniques available. The techniques are different from one another. That is, the procedure of sorting is different, but the end result is same. That is, you get an unsorted list, and if you want it in ascending order, you get a sorted list in ascending order. You can apply any of these sorting techniques, but the end result will be same, but the procedure or the technique is different. Different sorting techniques available are, some of them are bubble sort, which you have done, which is a common sort which you have done in 11th grade, and those who have done Java, like you have done your ICSE 10th grade with computer science, they would have done bubble sort there also. Then bubble sort, selection sort, bucket sort, shell sort, quick sort, heap, merge, insertion. All these are some of the sorting techniques available. For your syllabus this year, the sorting technique we would be doing is insertion sort. In insertion sort, they can ask you the trace of it. Trace is nothing but they will give you a list of elements and they'll ask you, by applying the insertion sort algorithm, please sort the following list in ascending or descending, whichever they say. You need to place the elements in that order, and even if they give you a completely sorted list, you need to follow the procedure, like the steps has to be followed, because it will be a 5 marker, and if you don't do that, you won't get the marks. Then they can ask you the algorithm for it as well as the program. It is also a practical program. So please pay attention. We will be doing the algorithm, the trace, as well as the program for insertion sort. The next, the first element, see, I can tell you, I will write the procedure and show it to you rather than explaining it from the figure, because you will not be able to understand anything from the figure. This is the same one which is available in your textbook also. So you can just make a note when I do this. The question, I will retain the same question. So consider the following arrays of 8 elements. So please make a note of this question, or I will be writing it. You can have a look. So let me write my array. What is my array? Here is 45. Then I have 26. Then 23. I have 56, 29, 36, 12 and 4. These are the elements of my array A. So if these are the elements, for example, I have, so let me say this is A of 0. A is my array. Then this one is A of 1. This element is A of 2. This element is A of 3. Yeah. This element is A of 4. A of 5. A of 6. And A of 7. These are the positions of the elements, that is number of elements in the array is 8. So 0 to n minus 1, that is 8 minus 1. 0 to 7 are the index values of the element. This is the array given to you in the beginning. So you need to apply the insert sort technique on this list to get a sorted list where the elements are arranged in ascending order. So I would be arranging these elements in ascending order. Okay. Please make a note of this question. Next is n, number of elements. That is how many elements? It is 8. Yes, the total number of elements are 8, correct? Because 0 to 7 is nothing but 8 elements. That is n is equal to 8. The n value is 8. So when I am doing this, like when I am doing a sorting technique, there is a concept called passes. So totally, to arrive at a result, you need to have n minus 1 passes. By the end of n minus 1 passes, that is number of passes, is equal to n minus 1. That is equal to 7, right? By the end of 7 passes, you would have arrived at the result. That is, you would have got your sorted list. By the end of n minus 1 passes, you arrive at the sorted list. This is the unsorted list what you have got. I have also the name of the array is A, and then I have given you the index location of each element, that is 0 to 7. So by the end of n minus 1 passes, you will get an array, that is the elements of the array would be arranged in ascending order. Fine. So let me start with pass 1. Pass 1. What is the array? Array is, I will use the same array, compare. There are two things here, comparisons, that is number of comparisons and number of passes. So in pass 1, what I will do is compare A of 1 and A of 0. A of 0. Compare, see, I am not comparing 0 to 1, I am comparing 1 to 0. That is, what is the elements? 26 and 45. So I have 26 and 45. When if I am arranging it in ascending order, there should be a swap because 45 is bigger than 26. So ascending order is the element starts from the least and goes to the highest one, the smallest to the highest one. So swap, right? There is a swap. What will be the resultant array? The resultant array after pass 1 is, see, in pass 2, what would be the array? The array would be 26, 45, 23, 56, 29, 36, 12 and 4. Okay. This is the resultant array because I compared A of 1 and A of 0, that is 26 is A of 1 and 45 is A of 0. Since I am arranging it in ascending order, it should start from the least, so there is a swap. So 26 is swapped in the position of A of 0 and 45 is swapped to the position of A of 1. Okay. So let me write the subscript values. Here in the exam also you are supposed to write this even if you get a completely sorted list also. So please make a note. A of 2, next is A of 3, A of 4, A of 5, 6, A of 7. Okay. So now compare. This is pass 2. Pass 1 I finished. How many comparisons are there in pass 1? There is only one comparison in pass 1. That is, I am comparing A of 1 with A of 0. The total number of passes is n minus 1. The total number of elements is 0 to 7 is nothing but 8. So number of passes. By the end of the 7th pass, I should have got my sorted list. So pass 2, pass 1, there is only one comparison. In pass 2, compare A of 2, compare A of 2 and A of 1. Okay. A of 2 and A of 1. What are that? 23 and 45. Yeah. 23 and 45. Yes, will there be a swap or no? There should be a swap. So, swap. So, what will be the resultant array? The resultant array would be 26. In the place of 45, I am swapping 23. And then in the place of 23, my swap would be 45, 56, 29, 36, 12 and 4. Now compare A of 1, A of 1 and A of 0. So what is A of 1 here? In the array 23, right? 23 and 26. So there is a swap. So 23 will go to 26 position and 26 will come to 23 position. So let me say that is the end of my pass 2. So pass 3. First, let me write the resultant array. You need to take the resultant array of pass 2, not the main array. So, there is a swap between 23 and 26. So, what was the resultant array? It should be 23, 26, 45, 56, 29. Sorry, there is no 29. Okay, yeah, there is 36, 12 and 4. So what is this? This is A of 0, A of 1, A of 2, A of 3, A of 4, okay, A of 5, A of 6, A of 7. So these are the array elements I have. By the end of the second pass, what was the resultant array? 23, 26, 45, 56, 29, 36, 12 and 4. What are the comparisons in pass 2? How many comparisons I did? I did two comparisons. One is the second with the first element, that is 23 and 45. There was a swap, and then the resultant array after the swap was 26, 23, 45, 56, 29, 36, 12 and 4. And then one more comparison, that is A of 1 with A of 0, that is 23 and 26. Again there was a swap, so I will be writing 23, 26, 45, 56, 29, 36, 12 and 4. So this number of comparisons with each pass is increasing. Pass 1 had one comparison, pass 2 had two comparisons. Now we'll see, we have got the resultant array for pass 3. So what are the comparisons I am going to make? Compare. What are the two things I am going to What are the things I am going to compare? First, I am going to compare A of 3 and A of 2, and then A of 2 and A of 1, and then A of 1 and A of 0. So, let me compare A of 3 and A of 2. Okay, I am going to compare A of 3 and A of 2, that is 56 and 45. 56 and 45, there shouldn't be any change. Yes, is there any change? No. So no change, because 56 is greater than 45. So you are not going to swap, and after that compare A of 2 and A of 1. What are the elements here? That is 45 and 26. 45 and 26. Again, no change. Then we'll say compare A of 1 and A of 0. Okay. What are the elements? 26 and 23. So, no change. I finished my pass 3 here. I did all my 3 comparisons. Since there was no change, I will retain the same thing but array. So, let me finish this pass. Now, pass 4. Totally how many passes? 7 passes I need to write. By the end of 7th pass, I should be able to arrive at the list sorted in ascending order. So what is the resultant array here? At the end of pass 3, whatever is the array you need to take. Since there was no change, I will take this array only. It is 23, 26, 45, 56, 29, 36, 12 and 4. These are the elements of the array. So it is A of 0, A of 1, A of 2, A of 3, A of 4, A of 5, A of 6, A of 7. So this is my resultant array after the third pass. So what is the pass 3? Oh, I forgot to write pass 4 here. It is pass 4. This is the end of pass 4. Compare COMP. Compare. First, I need to compare A of 4 and A of 3, then A of 3 and A of 2, A of 2 and A of 1, and then A of 1 and A of 0. So in pass 4, I will have to do 4 comparisons. So what are those? Compare. First is A of 4 and A of 3. So what are the elements there? 29 and 56. Yes, 29 is smaller than 56. So there is a swap. What will be the resultant array? 23, 26, 45. Then it is 29, 56, 36, 12 and 4. So this is the array after the comparison of A4 and A3 element, because 29, I am comparing 56 and 29. So 56 goes to the A of 4 location and 29 comes to the A of 3 location, since 29 is smaller than 56, and I am arranging it in ascending order. Now I am going to compare elements A of 3 and A of 2, right? A of 4 and 3 is done. Now 3 and 2. So what are the elements here? See, what is A of 3? 0, 1, 2 and 3. That is 29 and 45. 29 and 45. So there is a swap, because 29 is lower than 45. So what will be my elements? 23, 26. So 29, 45, 56, 36, 12 and 4. So there was a swap. Yes. Now I need to compare. What are the two elements? A of 2 and A of 1. A of 2 and A of 1. So what are the elements? The elements are 29 and 26. So 29 and 26. There is no swap. No, because 29 is greater than 26. So there is no swap. So now compare A of 1 and A of 0. So what are the elements? 26 and 23. 26 and 23. No swap, because again that is not there. Now I'll just say this is the end of pass 4. Now I have pass 5. To pass 5, what is my resultant array? The resultant array in pass 5 is 23, 26, 29, 45, 56, 36, 12 and 4. Let me write the locations also. A of 2, A of 3, A of 4, A of 5, A of 6, and A of 7. So now in pass 5, I need to have 5 comparisons. So as and when the number of passes increases, the comparison also increases. So it should start from, in the fourth pass, what did I start from? In the fourth pass, I started from A of 4 and 3. So here I will start from A of 5 and 4, 4 and 3, 3 and 2, 2 and 1, and 1 and 0. So total number of comparisons is 5. So compare A of 5 and A of 4. Okay. So what are the elements in A of 5? Element is 36, and what is A of 4? A of 4 is 56. So will there be a swap? Yes, there has to be a swap. So SWAP swap. If there is a swap, what will be the elements? 23, 26, 29, 45, and since here there is a swap, so 36 would go to 56 place and 56 would be swapped to the place of 36, 12 and 4. Now the next comparison would be A of 4 and A of 3. So compare A of 4 and A of 3. What are the elements there? For 36, 36 and 45. Do I have a swap here? Yes, 45 is greater than 36. So I should have a swap here. So swap, and then the resultant array is 23, 26, 29, 36 because there was a swap, 45, 56, 12 and 4. Now what are the comparisons I need to do? I need to compare A of 3 and A of 2, correct? A of 4 and 3 I did 3 and 2. So compare A of 3 and A of 2. So what are the elements I have? Which is A of 3, 0, 1, 2, 3. A of 3 is 36 and A of 2 is 29. So no swap. Next is compare what is the next element? Compare A of 2 and A of 1. What are the elements? 29 and 26. So no swap. Last one is compare A of 1 and A of 0. That is 26 and 23. 6 and 23. No. So we come to the end of the fifth pass. So how many comparisons I did? I did A of here 1, 2, 3, 4 and 5. So there are 5 comparisons. As and when the number of passes increases, that many comparisons also increases. Right? So now I am going to write the sixth pass. So pass 6. I have to write the resultant array of the previous pass. That is 23, 26, 29, 36, 45, 56, 12 and 4. So let me say this is A of 0, A of 1, A of 2, A of 3, A of 4, A of 5, A of 6 and A of 7. What are the comparisons in past 6? I will do A of 6 with A of 5, then A of 5 with A of 4, A of 4 with A of 3, A of 3 with A of 2, A of 2 with A of 1 and A of 1 with A of 0. So the number of comparisons are 6. So let me start with the first comparison. Compare A of 6 with A of 5. What are the elements? 12 and 56, correct? So definitely there should be a swap. What would be the array? 23, 26, 29, 36, 45, 56. 56 will not come here. 12, 56 and 4. Am I getting it? Because there was a swap there. So I just compared it and swapped it. Now compare A of 5 with A of 4. What are the elements? The elements are here 12 and 45, correct? 12 and 45 because this is 0, 1, 2, 3, 4, 45 is 4, 12 is 5. So there should be a swap. So what are the elements? It would be 23, 26, 29, 36, 12, 45, 56 and 4. Now compare A of 4 and A of 3. So what are the elements you need to compare? A of 4 is 12 and A of 3 is 36. 36. There is a swap. What should I be writing now? The resultant array is 12, 26, 29, 36. No, should I be writing 36 here? Here there's a swap, so it will be 12, 36, 45, 56 and 4. After that, compare A of 3 and A of 2. What is A of 3 here? A of 3 is nothing but 0, 1, 2 and 3. 12 and 29. That is 29 is A of 2. So there is a swap here again. So what would be the array element? 23, 26, 12, 29, 36, 45, 56 and 4. So now compare A of 2 and A of 1. So what are the elements? A of 2 is 12 and A of 1 is 26. So there is a swap. The array would be 23, 20. After that 12. Yes, there is a swap. 26, 29, 36, 45, 56 and 4. The last comparison is compare A of 1 and A of 0. So what are the elements here? 12 and 23. So there's a swap over there. The resultant array would be, I will write down the array. So what would be this? Pass 7, the last pass. Correct? The resultant array would be 12, 23, 26, 29, 36, 45, 56 and 4. This is my resultant array after the sixth pass. This is the array what I have. So this is A of 0, A of 1, A of 2, A of 3, 4, A of 5, A of 6, A of 7. So how many comparisons? A of 7 and 6. 1. 6 and 5 is 2. 5 and 4 is 3. 4 and 3 is 4. And 3 and 2 is 5. 2 and 1 is 6. And 1 and 0 is 7. So I am going to compare it. The number of comparisons is 7. So compare A of 7 and A of 6. Correct? A of 6. What is the elements over there? It is 4 and 56. So there's a swap. The elements would be 12, 23, 26, 29, 36, 45, 4 and 56. Right? Because there was a swap there. Now compare A of 6 and A of 5. So what are the elements? The elements are 4 and 45. So there's a swap. So the elements are 12, 23, 26, 29, 36, 45. Sorry, there's a swap, right? 4 and 45 and 56. So now let me compare A of 5 and A of 4. So what are the elements? It is 4 and 36. Correct? There is a swap here. So the array would be 12, 23, 26, 29. After that there was a swap, 4, 36, 45, 56. Compare A of 4 and A of 3. So what are the elements there? A of 4 is 4 and A of 3 is 29. So there is a swap, yes? So the resultant array would be 12, 23, 26, 4, 29, 36, 45 and 56. Now compare A of 3 and A of 2. So what are the elements here? The elements are 4 and 26, right? 4 and 26. So there is a swap. The thing is 12, 23, 4, 26, 29, 36, 45, 56. Now compare A of 2 and A of 1. So what are the elements here? It is 4 and 23. So swap, the thing is 12, 4, 23, 26, 29, 36, 45, 56. So compare A of 1 and A of 0. So what are the elements? It is 4 and 12. Swap is there. So the resultant array is 4, 12, 23, 26, 29, 36, 45, 56. So you can see here by the end this one completes my 7th pass. By the end of 7th pass I have arrived at a sorted list which is in ascending order. So you can have a look. When they ask in the exam, you need to write it this way only. Whenever you get an unsorted list, you need to count the number of elements, that is total number of elements minus 1 is the number of passes required to arrive at the result, whether you are arranging it in ascending or descending, but the number of passes would be n minus 1. In insertion sort, the thing is each pass, the first pass you have one comparison, you compare from 1 to 0, not from 0 to 1, okay? The first pass you have one comparison, in pass 2 you have two comparisons, and whatever is the result of that pass, that array you need to take for the as the input for the next pass. You cannot take the original array because once you swap it you would have changed the array elements location. So in the third pass you will have 3 comparisons like that. In the fourth, 4 comparisons. Fifth, 5. Sixth comparison, and in the seventh you have the number of comparisons is 7, but then the total number of elements was 8. By the end of the 7th pass, I arrived at my sorted list which is arranged in ascending order. Please have a look Go through your notes. This is how you're writing the trace. If you understand this, then understanding the algorithm and the program is very easy. So hope you have understood the trace, that is the procedure of insertion sort. Tomorrow we'll continue with the algorithm as well as the program. Please note down the homework question. Write a program to search for a given element in an array using binary search. Give the difference between, or I can say list the difference between binary search and please make a note of this. Hopefully you have understood today's lecture. Stay safe. Take care. See you tomorrow. Bye bye.